Okay, good afternoon, everyone. I hope you are doing great. I have already provided a package for you on the course outline. And I would be thankful if you download it from there. This is the add class code. I just copied. Could you please confirm if it works? Okay, thank you very much. Also, to ease the job, I send you the package here as well. So you can simply download that package and you should be able to have something similar to this after downloading. So it should contain 4 different files. Whenever you download and you finish unzipping it, take your time. After that, please just give me a signal by typing 1. Sherry, thank you. Alexis, Matthew. Justin. Awesome. Jacob. Sivan. Ako. Okay. Excellent. No. After that, you need to go to the Colab environment. Let me close my cam. Then drag and drop, please, this interactive Python notebook. I resent Murad the zip file again. So here's the file, please unzip it. I go slowly to make sure that all of our team members, they are on the same page. So today's agenda is all about object-oriented and the classes that we have. Definitely, it's not a small topic that we can just finish all the aspects of it in one session. We consider that mostly the general idea of the classes compared to the structured programming. Let's quickly review, then I can make sure that more people are in the session. The code that you're going to work with contains the class concept. So code the constructor for a class that has attributes and methods. So it says just attributes and methods, but do we have only attributes and methods? That's the question. Import a class, how to do importing, create objects from it, access the attributes of the objects, and call the methods of the objects. Use object composition to combine simple objects into more complex data structures, and use encapsulation to hide the data attributes of an object. So for that one, we know that we have fields and we have properties. So properties help us to be the way that we can access the fields in our program. Let's quickly go through the knowledge objectives. We are going to quickly go through the UML class diagram and describe the relationship between a class and an object. In general terms, describe the identity, state, and behavior of an object. In general term, describe the way Python code is used to define the constructor. its attributes and its methods in general terms describe the way Python code is used to create an object from a class, and describe the concept of object composition, describe the concept of encapsulation, and distinguish between public and private attributes. So you might say that we don't have only public and private. Just imagine we are talking about a simplified version of object-oriented in Python. That's something like the concepts like protected and the internal are going to be divided into these public and private. You can see more sophisticated mechanisms in languages like Java or C#, but here we have a simplified version of the concept. Describe the use of getter and setter methods, so accessors. And these are the things that we are going to extensively work on today. And hopefully at the end of the session, you have a clear understanding of all the above mentioned topics. Guys, if you have the file and you already see something similar to this and there is no problem, please give me the first high five, please. Thank you very much. Okay. There's a question, what are the differences between classes and objects? So we can consider classes are like blueprints. Here is a map of a house, but definitely if somebody has this blueprint, cannot invite their family and friends in that blueprint. You need to make that real. Converting a class to an object is exactly like converting a blueprint to a house like this. It's exactly the blueprint of this one. So you see here is the actual, right? And this is another example that we see the implementation of a building. It's constructed based on this blueprint that you see. So we have the same concept in programming. In programming, you define a class by telling the attributes. It could be in the form of fields or other parameters that we have in a class, and functionalities that we could have. One of the functionalities that we have is a constructor, and the other actions that we want the class contains. So in this example, we have 3 different attributes, to be more precise, fields. And we have 3 different methods. So constructor is a kind of method, not exactly, we don't have the same return thing that we could expect from the others, but it does something for us. So in that case, because it does an action, it's under the umbrella of methods. So what could be the relationship between classes and objects? Guys, if you have a blueprint of Toyota RAV4, for example, it doesn't mean that you can write from it, right? You can use it to go from A to B. You need to go and order something, and they produce something with the specific color that you have in mind, the interior that you order and everything, and then they make an object, they make a car out of the blueprint that you have. So here we have a blueprint, a product that contains name, price, and discount person. Then you're going to create one product 1, which is this one, and product 2, which is the other thing. So they are not exactly the same. It's exactly like a blueprint of a car. Somebody could order a white car, the other person could order a blue car, the other person could order a white car. So they are different products from the same blueprints, just in the values that you assign to attributes, to fields, would be different. Okay, what is UML diagram nodes? I searched and I found a very concise and nicely explained UML in this YouTube video. So I'm going to share that with you here. Hi, my name is Zach, and I'm with Lucidchart.
Today I'll be teaching you about UML class diagrams. We'll start with some of the basic characteristics, then we'll talk about relationships, and we'll finish up by going through some examples together. All right, let's talk about some of the basic characteristics of class diagrams. To help explain these characteristics, I'm going to make up an example to help illustrate. So let's say we're building a system for a zoo. And by the way, these examples I'm going to use.
Okay, just guys, is everything clear at your end? Can you hear? And okay, thank you. Let me just increase the volume. Well, that's why I pause it to make sure that if everything is fine.
Probably wouldn't ever find a way into an actual program, but it'll make all these concepts easier to understand. So in our zoo, we want to describe the different things that are in the system. You represent those things through classes, and a class is depicted with the shape here. So what's in a zoo? Well, there are a ton of animals. So we can create a class for our animals.
Just one thing before I go further. Here is the link for you. You can start watching it from there. And after you are done, I'm going to pause for 10-15 seconds to make sure that everybody return from there. So you can mute me and just watch it. Whatever works for you the best. Okay, let's continue.
To do that, you just write the name of the class in this top section. If our class is animal, an instance of that class would be a specific animal. So the question is, how would you go about identifying each instance of that class? You do that through attributes. An attribute is a significant piece of data containing values that describe each instance of that class. They're also known as fields, variables, or properties. And they go in the middle section here. So for our animal class, we could create attributes like name, ID, and age. That way we could identify a specific instance of the animal class, like Ruth, ID number 304, age 114. These need to be formatted a certain way though. You start with visibility, which we'll talk about later, the name of the attribute beginning with a lowercase letter, then you follow it with a colon and the data type. For the name, we want to return a string, and we can format the other attributes the same way, except that we want to return an integer since these are integers. Now that we've got some attributes for our animal class, we get to the bottom section here. This is where you put methods, which are also known as operations or functions. Methods allow you to specify any behavioral features of a class. So we might ask ourselves, what are some different behaviors of this animal class? Maybe we'd want to be able to change our animals' names. Like Ruth should actually be called Rita. So let's create a function called setName. We can also create a method for eating since all of our animals eat. Methods also need to be formatted a certain way. You start with visibility, which we'll talk about next, then the method beginning with a lowercase letter. Next, you put parentheses to signify the function you want to program later. You can also add variables and the data type in here, but in most cases, it's not really necessary. We'll add visibility parentheses to the eat method as well. Now let's talk about the visibility. The visibility of an attribute or a method sets the accessibility for that attribute or method. So right now we have a minus sign for all of these, which indicates that each of these attributes and methods are private. They can't be accessed by any other class or subclass. The exact opposite is the plus sign, which means an attribute or method is public and can be accessed by any other class. Another visibility type is indicated by the hash, which means an attribute or method is protected. These can only be accessed by the same class or its subclasses. And finally, there's the tilde, or the squiggly as I like to call it. This sets the visibility to package or default, which means it can be used by any other class as long as it's in the same package. But that one is rarely ever used. In most cases, your attributes are going to be private or protected, and methods are often public. Let's quickly review these basics with another example. Let's make a class for employee. We could give an employee the attributes of name, employee ID, phone number, and department. We'll want all of these attributes to be private, and then we could create a simple method like updating the phone number, which we'll go ahead and set to public. So you may have noticed that I'm using diagramming software to create these UML class diagrams. The same principles apply if using pen and paper, but diagramming software makes it much easier. The diagramming software I'm using today is Lucidchart, and you can sign up for free by clicking on the link at the top right. All it takes is an email address, and then you'll be able to follow along as we make these class diagrams. So the next thing we'll need to cover are the different relationships that exist between classes. The first type of relationship that we'll describe is inheritance. I'm going to keep going with the zoo example because it makes it easy to understand the logic of these relationships. We'll get to a more technical real-world example later. Okay, so inheritance. Let's say in our zoo, the only animals we have are tortoises, otters, and the lesser known, but nonetheless amazing slow loris. In our system, we want to distinguish each of them as their own class. So we make 3 new classes for tortoise, otter, and slow loris. And I'll make these a little smaller so you can see them better. Now, instead of duplicating attributes for name, ID, and age, we can make these classes into subclasses of the animal class by drawing open arrows like this. This is an inheritance relationship. We're saying that these subclasses inherit all the attributes and methods of the superclass. You could also use the terms child and parent class. So our otter class is going to inherit the attributes of name, age, and ID. And then we could add an attribute specific to otter like whisker length. One of the advantages of inheritance is that if we wanted to change or add an attribute for all animals, we wouldn't have to go in and make that change to tortoise, and then otter, and then slow loris. We could just make the change to the animal class, and it applies across all subclasses. In this scenario, we also have what's called abstraction. Animal is an abstract class. Because in our system, anytime we want to instantiate one of our classes, it's going to be a tortoise, otter, or slow loris. We wouldn't instantiate the animal class itself. The animal class is just a way to simplify things and keep the code dry so you don't repeat yourself. So to show that this is an abstract class, we'll put the name in italics. You could put the name inside these things as well, but I prefer italics. Okay, another type of relationship is association. So if we had a class for sea urchin, we could draw an association, which is just depicted by a simple line, between otter and sea urchin. And we'd say otter eats sea urchin. There's no dependency between them, it's just a basic association relationship, and it's pretty simple. The next type of relationship is aggregation. It's a special type of association that specifies a whole and its parts. So to continue with our zoo example, again, this is just to help explain the logic. Let's create a new class for a group of tortoises. A group of tortoises is called a creep, and that's pretty cool. So here's our creep class, and it's got a relationship with tortoise. Any of our zoo's tortoises could be part of a creep, but they don't have to. A tortoise could leave the creep at any point and still exist on its own. That type of relationship where a part consists outside the whole is aggregation, and we know it with an open diamond. There's also a relationship where the part can't exist outside the whole. It's called composition. To illustrate this, I'm going to create a few new classes. Let's just say we have several different visitor centers in our zoo, and each of those visitor centers has a lobby and a bathroom. Now, if one of our visitor centers was torn down, the lobby and the bathroom of that visitor center would be destroyed as well. Those rooms couldn't exist apart from the visitor center that they're in. That's composition, when a child object wouldn't be able to exist without its parent object. We know the composition relationship with a closed diamond. Another important concept when talking about relationships in UML class diagrams is multiplicity. Multiplicity allows you to set numerical constraints on your relationships. For example, let's say we want to specify that our visitor centers are going to have just one lobby. We simply write the number 1 here, meaning that there can be one and only one lobby per visitor center. But for bathrooms, maybe we want to make it so that there's at least one bathroom per visitor center, but leave the option to have as many as you'd like. We'd use this notation to denote one or many bathrooms. Other types of multiplicity are 0 to 1, which is an optional relationship, n representing a specific amount, which in our example was 1, but it could be any other number depending on your use case, 0 to many, 1 to many, or a specific number range. Hopefully our zoo examples have helped explain those concepts, but I want to show you what a real-world example would look like. This is a UML class diagram for an online shopping cart, and if you want to look at this diagram with me, just click the link in the top right corner. You can see that the system has several classes and relationships, so let's walk through a couple of them. We'll start with the user class. It's got attributes for user ID, password, login status, and register date. You've got the different return types on the right, and on the left, visibility, which are set to private. You can see how the values returned by these attributes would specifically describe an instance of the user class. Down below, we have a public method of verify login, returning a Boolean. And this makes sense, right? Methods are behaviors of a class. So if you were to log into your user account, there's a function in place that verifies your login credentials. Let's move on to the customer class. This arrow tells us that customer is a child of user. So customer inherits all of the attributes and methods of the user class. And same thing for the administrator class. Both of these inherit from the user, but also have their own specific attributes and methods. Like administrator can update catalog, but customer can't. Stemming from customer, there are several lines with the closed-in diamond. So if you recall, these are composition relationships, which means that the parts cannot exist without the whole. If an instance of the customer class, if that customer's account was destroyed, his shopping cart would be destroyed and his orders would be lost. They can't exist outside of the customer. The same applies for shipping info and order details. If there's no order, there's not going to be any order details or shipping info. The last thing we'll look at in this example is multiplicity. You can see that a customer can have 0 or many orders. Makes sense, right? You could create a customer account for an online store but never buy anything. Or you could be a frequent customer and place several different orders. Now, on the flip side, an order can belong to only one customer. It'd be pretty confusing if a specific order with a unique order ID was duplicated across several different customers. And here you can see a one-to-one relationship. Each order has one and only one order details, and order details belongs to one and only one order. Thanks for watching this tutorial on UML class diagrams. Be sure to subscribe to the channel and leave a comment below. Lastly, don't forget to sign.
Okay, I'm gonna wait for a couple of seconds to make sure the other friends finish watching it. Whenever you are done, please type 2. Alexis, thank you. Go, Matthew. Abdul, Ken. Ahmed, Sharon. Wilson. Okay. I hope you enjoyed that among all the videos that I could find. That was the best. Very concise and right to the point. I found something similar to define classes. So we already got some ideas about the UML. It really deserves to have 14 weeks every 4 hours to learn UML. But the most important parts of it were discussed in the video. And now using the UML concept in defining the classes, this is a short video that I found very useful, very concise. And right after that, we are going to start working on our own classes in Colab. So this is a new video. The same way, if you prefer to watch it individually, you can just mute myself for the next 12 minutes. I'm going to continue at 2:37. So feel free to start watching it individually, or you can just watch with me.
Hey guys, in this video, I'm going to give you a quick introduction on how to use classes and objects in Python. I'm going to assume that you're already familiar with these concepts. So if you're new to the concepts of classes and objects, I'd recommend my introduction to classes and objects video first. Okay, so here's the class we want to create. It's going to be called Robot, and it'll have 3 attributes or 3 instance variables: name, color, and weight. Those are the name of the robot, the color of the robot, and weight of the robot. And then it's going to have one function, introduce self, where when you run this function, it'll just print out my name is the name, whatever the name is. And from this class, we want to create these objects. The first object will look like this. It's going to have the name Tom, the color is going to be red in a string, and the weight will be 30 to show that it's 30 pounds. It's going to be an integer. And we're going to put this object in a variable called R1. And the second object we're going to create will look like this. This robot will have the name Jerry, the color will be blue, and weight will be 40. And then we're going to put this object in a variable called R2. So let's now see how we can create this class called robot and these 2 objects out of that class in Python. The first thing we need to do here is, of course, we need to create a class. For that, you can just write class robot colon, and notice here that R here is capitalized, and then 4 spaces after that. And we're going to implement the function we saw earlier, introduce self. For that, you can just write def introduce underscore self, parentheses, colon, and 4 more spaces after that. And then print, double quotes, my name is plus self.name. And this keyword here, self, is sort of like this in Java. And it will refer to whatever object we're running this function on. So for example, if we run this function, introduce self, on an object whose name is Tom, this is going to print out my name is Tom, because self will refer to that object. Now this function, if you see, it looks like a regular Python function. We're defining a function called introduce self, and then below that we have some implementation. But actually, when this function is within a class, when this function is a method of a class, you need to add an additional argument, and that's going to be called self. So this self is exactly the same as this self right here. So in Python, basically you need to add this additional argument called self to every method you want to add to this class. And once you run this block of code, this class is going to be created. And you might say, what about the attributes like the name, weight, and color? We're going to worry about that later. So let's run this block of code for now. Now that we have defined this class, we'll be able to create an object out of this class. To do that, you can just write R1 equals robot, parentheses. Again, note that the word robot is capitalized here. And this simply says, create a new object with the class robot. And here you're using the default Python constructor for this class robot. And to set the attributes, you can just write r1.name equals Tom, r1.color equals red, and r1.weight equals 3. And when you run this cell, a new object has been created. It's assigned to R1, and then its attributes have been set. And then if you want to run this function, introduce self, on this object, you can just write r1.introduce self, parentheses, and you don't need to pass in any arguments here. And when you run this cell, what's going to happen is it's going to go into this part of the code, and then self will refer to R1. And so this part of the code will look like print my name is R1.name, and R1.name is of course Tom here. So it should print my name is Tom. Let's see if it works. And it did. We see my name is Tom right here. And just like that, you can create another object too. Let's go back into this cell and let's write R2 equals robot. This will create a new robot object. And then let's set its attributes too. So R2.name equals Jerry, R2.color equals blue, and R2.weight equals 30. Let's actually set the weight of R2 to 40, like we saw earlier. And once you run this cell, you'll have an object in R1 and another object in R2 with different sets of attributes. And then at this point, you should be able to run R1.introduce self and R2.introduce self. So the first line should print my name is Tom, just like we saw earlier. And then the second line should print my name is Jared instead. So let's see if we can get that. And that's exactly what we see. Okay, going back a little bit, when you see this block of code that we use to create these two objects, you might say, well, that's not great. Because here we're writing r1.name equals Tom. But if we misspell the word name, for example, if we wrote r1.name equals Tom, it's gonna stop working. Because if you look at this function in particular in this class, we're writing here print my name is self.name, and this piece of code basically depends on us writing the attribute's name correctly for it to work. What I mean by that is, for example, if you misspell the word name by writing r1.name equals Tom, the attribute called name does not exist in this object anymore. So we can actually see what's going to happen if we try that. So let's run this cell again. And this is not going to give us any error because when you write r1.name equals Tom, the attribute called name is just defined and then the value Tom is set for that. But when you run this block of code, r1.introduce self, let's comment out the second line and let's focus on the first line. When you run this part, it'll say attribute error. And it says robot as object has no attribute name. And that's because it has the attribute name me, but it doesn't have the attribute name. So this is probably not the best way to deal with different attributes we have. Let's see how we might be able to fix that. And the way you can fix it is basically by using a constructor. And in Python, you can create a custom constructor with this keyword, underscore underscore init, and that's underscore underscore. So there's the word init, and it's surrounded by pairs, 2 pairs of underscores. And then parentheses, and let's have this function take 3 arguments. Given name, given color, and given weight. So these are the name, color, and weight we want to set for this particular object that we are trying to create. And then we can write here self.name equals given name, self.color equals given color, and self.weight equals given weight. And this block of code, of course, says set this object that we are just creating, set that object's name to given name, and set that object's color to given color, and set that object's weight to given weight. And earlier I said you need to add this self keyword, this additional argument to every function we define in this class, and the constructor is no exception. So you actually need to write self as the first argument, and then the arguments that you want to add in. And actually, just like many other languages, a common practice here is to name these arguments exactly the same as the attributes that we want to set. You don't have to do it, but that's a style thing. So let's just do that. Let's change given name to name, and then given color to color, and given weight to weight. And once you run this block of code, this class is going to be refreshed with a new constructor. Once we have a custom constructor in our class, the default constructor that we used will stop working. So let's just comment out this block of code, and then let's rewrite it using our new constructor. For that, you can just write R1 equals robots, parentheses, Tom, comma, red, comma 30. Let's capitalize Tom here. And then R2 equals robots, Jerry, comma blue, comma 40. And these 2 pieces of code do exactly pretty much the same thing as what we saw earlier. But as you can see, this is much cleaner because you don't need to specify the attribute names manually every time. And just to reiterate, just to sort of clarify, this line R1 equals robot, Tom red 30 will create a new robot object, and then it'll set Tom as its name because Tom will go in here as the name argument, and then it'll go in here, self.name. And self, again, will refer to the object that we're creating. So it's sort of like saying R1.name equals name, R1.color equals color, just like we did earlier here. And of course, it's the same thing with R2. Okay, and to make sure we don't have anything left from the previous code we were using, let's go to kernel and click restart and clear output. This is going to clear out every variable we defined earlier. And then let's load this class again, and let's run this cell. And at this point, we should have R1 and R2 objects defined. So we should be able to run R1.introduce self and R2.introduce self. And that should print exactly what we saw earlier. My name is Tom and my name is Jerry. So let's see if that works. And it does. All right, you'll be able to find links to the sample code I used in this video in the description below. And if anything was unclear in this video, please let me know in a comment below.
Okay, take your time, especially those friends that they use the link. Whenever you are done, please type 3. Thank you. Murat, in languages like Java, like C#, we use constructor using the same name. We always define that the constructor in a class is a special type of method that has no return. And the name is the same as the name of a class. Am I right, Murat? I repeat it, in languages like Java, C#, constructor is a specific method inside a class that the name of that method, I'm talking about constructor, is the same as the name of a class. Is it correct? Okay. Here in Python, we use underscore underscore init, underscore underscore. This is exactly a specific method, which is a constructor. Right? Sharing what? Guys, can you see the screen? Well, I haven't shared anything yet. I just answered the question. That is another, okay, Murat, if you don't mind, wait for a couple of minutes. You're gonna receive the answer for that, but let me just quickly go to this part for you. Here, when we say in the modified version of the code, when we modified the constructor by saying underscore underscore init, means that if I pass something like Tom, which is going to stay here, red in color and 30 in the weight, I create an object, let's call it R1, using that constructor. We didn't do anything else. This is just responsible to create an object. And we have tons of examples, so just please be patient. This time, after this, we just called one function. You could do it, you could just omit that part. We could just want to see how it works. We could define 10 different methods. This is just one simple method that we wanted to say, yes, R1 is already created, and the name is, my name is Tom, my name is Jerry, kind of thing. Okay? Yeah, don't worry about it. Yes, this is the second method. So we have def for definition of, the first one is definition of constructor, but the second one is the definition of a introduced self. It could be Reza, it could be ABC. The name is not a reserved word. Okay, thanks for asking, Murat. Let's go to this example. For some of the parts, my pleasure. For some of the parts, I just have screenshots, and I'm not gonna take your time. So at your convenience, please go to the provided links for further explanation. But the simplest class that we can create is a class that has nothing. So if you just say class box, as you see here, and you do nothing inside, it's gonna raise error. Just to say, hey, do nothing and receive no error, you're gonna say pass. Now, the pass statement is used as a placeholder for future code. When the pass statement is executed, nothing happens, but you avoid getting an error when empty code is not allowed. For instance, inside in this example, you're gonna see, for instance, inside a loop, it is not possible to just do nothing. To say that do nothing, you just say pass. It's like here for this specific code that we want to iterate over these numbers. We don't want to do anything, so we just say pass. And the constructor, as our friends already asked, and we went through the video, it says that we need the ability to add build to the class object. And one of the ways, I emphasize that one of the ways is using constructors. right? And have a new box object constructed with the name of my box with the width is 12, height 34, and the depth is 56. Everybody please run this code. So in here, now we know that we define a class. The constructor is this line, second line, which contains self, which is a part of, as the video clearly said, we always use self. It is something like this in C# or Java. And then we have these three parameters that we do nothing with them yet. So guys, these are not fields. Yes, Jam asked the question, is it necessary to have it? Yes. For the objects that we create based on the class, self is mandatory. Whenever you want to address the class itself, we're going to see it almost near the end of the lecture today. We use CLS, which stands for the class. But for any object that you create, self is a kind of mandatory to say, hey, we are talking about, for instance, Tom or Jerry, based on the examples that we saw a second ago. So multiple constructors are not allowed. This is something that we have in other languages like C# or Java. We use multiple constructors, and based on that, it really depends on the number of parameters that you pass to the constructor. You're going to use first, second, third, or any. Here, if you want to use multiple constructors, you just combine them, compress them into one, as you see here, and you define default values. So if you don't pass height or depth, it's going to consider them as zeros. So again, we do not have, that's a good thing for remembering. I'm not sure if this is one of the quiz questions or not, but I think that it was important to me. So to make constructors, parameters optional, instead of using several and not having height or depth, you're going to just define those values equal to 0 or the default values that you want to pass. So to create a constructor with no parameter, the constructor that has no parameter is called parameterless or default constructor. Okay, so for any parameterless constructor or default constructor, you just need to say self. This is the simplest thing in many languages, like C# Java. If you do not mention any constructor, a compiler is going to provide a basic default parameterless for you. The constructor we'll choose for our box class will be the second constructor. The question that I received from Fatima is, what is the use of constructor? Constructors are responsible to occupy memory for us. If you do not say, if you do not use constructor, where is the memory allocation? You know what I'm saying? So you need to put a label and say, hey, this is something, please provide that. I want to. It is like, Fatima, it is like you have a plan for your home, but you need to buy a land for it. A basic constructor means have a flat field that you are going to allocate the other attributes, means the number of rooms, for example, the other features like the color of the walls and so on later. But first you need to occupy a land for that. In computer, we could say we want to allocate a memory. In many languages, when you say, for instance, my class equal to new class, that kind of thing, and you use parentheses, you call constructor. You know what I'm saying? Give me a second, please. Imagine that you have a class called math. You say my math equal to new math, that kind of thing in languages like Java, C#. Here, when you say new and you call constructor, means that go to the memory. New is responsible to occupy memory, and how much memory you need. This is going to be defined by the constructor. Okay, we are going to see the usage a little bit later. I hope I answered your question. I tried to answer it briefly. So look at here. In this class, let's call it box. We define a constructor, self is mandatory, to say that this object that I create has at the beginning no name, width is 0, height is 0, and depth is 0. The good thing is I know that I need a memory allocation for name, whether I use it or not at the moment. I need to have an integer place for width, whether I use it or not now, the same for height and depth. And because I don't do anything at the moment, I just say pass, right? Okay, to simplify the job, everybody, please open this part. Please open this part. For those friends who joined us later, again, I send you the package. Please make sure that you download the file and you unzip it. And you should be able to see something similar to this if you decompress. I wait for a couple of seconds to make sure that everybody could download, unzip, and just see similar things. Before I get further, the intention of this toy example is just using two separate Python files, Python classes that we have here. Just please right click on that, use the notepad, the simplest thing to just work with. And see, it's going to tell you in class named mybox, we have the simplest form of constructor. We do nothing with them. In the second class, which the name is mybox2, we get all these parameters like a name, width, height, and depth, and we are gonna pass them to self.name, self.__width, self.__ height, and self.depth equal to depth. You see that? This is the thing that we have in box class Python, and in new box class, just let's open that one too. Again, we have my box. I just wanted to use two different imports. That was the intention, guys. We could merge it together. This is just a toy example. In the third one, we exactly do the same thing. Imagine that it is different while it is not. We have another class named mybox3, and we have a constructor that we receive all those parameters from the user, and then we are going to pass them to the fields that we have. The thing is, if you see, two of them are a little bit strange compared to the other fields that we have. They started with __. So the reason of having those will be explained in a few minutes. But I just wanted to know that you could just download and open the files. And after that, just please click on these files. It's going to open a room for you. And then simply you can drag and drop this one here. You can do both at the same time. I just wanted to do the step by step and drag and drop this one. Let me just open this again. Below the key sign, there's a folder sign. You click on that. And it should be just sample data at the beginning. So I already dragged and dropped the new box class as well. So you see that we have all these things here. Definitely, if you double click on them, you can see the content of them on the right side as well. So you can just close them. I'm going to just specify more room for the rest of the things that we are going to do, right? So everybody, would you please confirm that you could see the shape that I see on my screen similarly? And if everything works fine at your end, would you please give me the next High five, type 5. Tomer, thank you. Fatima, thank you. Sherry, Fatima, Tomer, Alexis, Matthew, Samuel, Abdul Ghaffar. Oleg, thank you. I appreciate it. So guys, now it is 2:52. Let's have a 10 minutes break, and we are going to come back at 3:03. I'm gonna mute myself, and let's just have that 10-minute break. Thank you very much. Okay, if you can hear me clearly, please type 1. Thank you very much. We're gonna start in less than a minute. Here is the add class code again. And for those few friends that by any chance, they didn't have a chance to download the package for week number 11, you already have it. Please unzip it. You should be able to see something similar to this one. And then first, open your Colab, drag and drop this to upload, and in the folder section, drag and drop these 2 files. Okay, so let's continue. Here we said, let's define a class box. We just have a constructor, which we didn't do anything with it. And then the other one is a default constructor that Fatima asked, what is the use of it? Just to occupy the memory for the object that we might use. Remember, self represents the object. And then in the next one, again, we define a simple constructor that we do nothing with it. And then we import the classes. Look at here. Here we have one file. The name of the first file is box class. So we say from box class import mybox. Remember, in this file, we have 2 different classes. So each file could have several classes. We say first go to that file and then import mybox, which is the first. And then we are gonna just pass the parameters. The mybox1 is going to sit in here, 12 in the width and height and depth. And mybox2 is another object that we create based on that. And in mybox3, the difference between mybox2, 3, and 4, with the first one is, as you see, in mybox2, we don't have any value for the depth. So the default value, which is 0, is gonna sit for depth. In the box 2, in the box 3, we don't have any value for height and depth. So zeros would be inserted for the height and depth respectively. And for the last one, we only have the name part, but we don't have anything for width, height, and depth. So the default values will be sit over there. The problem here is if you say, okay, show me the box 1, it's not going to show you the name. It's not going to show you the width, height, or depth. It's going to show you, Fatima, do you see this number? This is the address of box 1 in the memory, right? So the constructor, yeah, lovely, location in the memory, right on. So this is because of having the constructor, the one who started with init, right? The one who started with init. This guy is responsible to occupy a location in the memory. Let's go to the next one. And in the next one, guys, if you say box1.name, you're not going to get anything out of it. It's going to just raise error. You see, if I say name, for example, right? What is happening there? There is no name the way that we have it in the second one. So it's going to just raise error for us. But in box 2, we are going to say, let's create box definition 1, and we use mybox 2, we use this one, and we pass all those things. And we pass hello from Reza into the name part. And if we say, okay, show me the value, let me just run one at a time. If I say, show me the name, it's gonna show Reza, right? Let me ask you one thing, guys. What do you think if I say, show me the, if I say dot, and if I say, show me the depth, what's gonna show? Any guess? 12, 34, or 56, which one? Excellent. It's gonna show 56 because this guy, and if I tell dot and I use width, what is gonna show me? Tell me. If I say width. But surprisingly enough, it's gonna show error. And the reason for that is you're not allowed to access widths because of underscore, they are private, right? So let's see what we can do for such cases in no time. Let's bring this back to name and then go to the next part. So for the last one, I said from new box class, you remember that's this one. Go to the last one and import the last class. And one of the thing is destructors. Destructors, or in some languages, you might hear finalizers. Almost 20 years ago, that was the responsibility of the operating system to take care of that using the compiler's facilities to manage their memory, getting rid of all the garbages in the memory. So garbage collection was a routine that they tried to just manage them between, it happened between operating system and the compiler. The more recent version of that is putting the responsibility on the shoulder of the class by itself. When the class is terminated, the object of a class is terminated, that class is responsible to free the memory by itself. So technically, we do not have the concept of destructor the way that we had it 20 years ago. It really deserves to have 20-30 minutes to talk about it, watching some videos and discussing further. But for now, what we want to just know is something. When you want to go to that old road and you want to destroy or delete a current object, you say, for instance, let's define the mechanism that you want to get triggered when you delete that object. So let's just see in here. In class box, we have a constructor and we say underscore del, and this is destructor. And we say, so please say destroying box. Let's just run this one together. And you can just see I have provided for you, there's no time to go through it together in the class. So please, if you are interested, watch that at your, read it at your convenience. This is something like that. I have a class, that's the gist of that actually note. I have a class employee and I have the constructor and I have destructor. So if I say, let's create one object based on that class, it's going to be something like this. And when I say del object, let's see what's going to happen. Look at this one. If I say I'm going to have a class employee and then object obj is going to get created based on calling the class constructor. So it says that employee is created, right? Employee created. But when you say del obj, I expect to have something like this. But why it doesn't do? Sometimes it does, sometimes it doesn't. But if you want to see, let me tell you why it doesn't show at the moment, because you already got outside the object which exists in here, so garbage collection takes care of it automatically. So it doesn't mean there isn't anything that you want to delete. But look at this one. If everything happens in one cell, you can see the creation and the deletion at the same time. Not a bad idea. Just search why it doesn't work in this condition. Just search, you're gonna see nice content in Stack Overflow specifically. Okay, this is another example that I have found for you. So the structure alongside with the existence of constructor. If you delete the object, it's going to get triggered. And it's going to show you the structure as well. Okay. So getting back to the standard class, and from now on, we don't need actually, well, if I close it, doesn't mean that it's going to just close this up. As long as we are inside Collab, it's going to be there. They're going to be there. Okay, let's have a class definition. We have a constructor that we have 4 parameters. We pass them into name, width, height, and depth field. So we create box 1, and now we can just access name, width, height, and depth. But what if we define a private property or field or something? Technically here, we haven't started talking about properties yet. But if you use underscore there, let's just see, and I redefine that. This one is going to work. This one is going to work. But this one, when you say width, because it is private, remember, it's not going to show. Let's go to the next one. In this case, the same thing. We have width and height as private members. And if you look at this one, I have commented because it's going to just show us error. So for box 1, width, I tried everything, like all the possibilities. How about saying width? How about saying underscore width? How about height? The same thing. So it's going to just show you error. But the depth, because we didn't say that, it is private and it is publicly accessible, it's going to show the content of it, which is 56. Okay. Before removal of the unavailable properties allows us to run error-free. Before that section, please make sure that you could run all the parts. I wait for a couple of seconds. And when you got there and everything is fine, please type 1. Matthew? Abdul? Sherry? Fatima? Murad? Nigar, can you hear me? Are you in the class? If you can hear me, please type 1. Okay, I repeat the comments that I had at the beginning of the session, and that was whenever I upload a video, it takes a couple of hours, sometimes 4 hours, to get to the high quality. I checked it after 4 hours, 4K was accessible. So at the beginning, it doesn't show the high quality. Please wait for a couple of hours if you want to get the highest possible quality. It's a process that happens behind the scene. Okay, so let's go to the next part together. Let's define an object box1. And then if I say print box1.name, trying again. And then if I say print box1.depth, it's going to show. But now we can relate to the fact that sometimes we need our attributes to be private. Because we just wanted to initialize them, we do not want to show back those things. There are cases, you might say that, what is the point of that? Well, first thing, security. Many a time we don't want anybody who passes, they just say the name of an object dot, and they can access all the attributes that we have in the object. There's a kind of security threat for such cases. For instance, what if you get the credit card number and you just want to show, when somebody wants to get the credit card, you just show the last 4 digits. So you don't want to show everything. That kind of cases. Plus, in many cases, you want to have a control over the values that you receive from user. For instance, if somebody by mistake, instead of a score for a grade for a course, which should be between 0 to 100, if that person enters something like -10 or 1,234, both numbers are not acceptable. So you want to have a kind of management or control over the input-output kind of thing. So in those cases, you don't want everybody access those fields. You want to have a control, and if there is, if it is not an appropriate input, you want to raise an error or show a message and ask the user to re-enter the value. So for such cases, let's see what we can do. Imagine that we make height and width just hidden, but we want to show the area, which is the multiplication of height that private height and width. In such cases, look at this. I say define area in here. And guess what's going to happen? So the area would be multiplication of height and width. These private members, because they are inside the class, they can be accessed within any method that we have inside the class. And remember, always we need to use self, if you remember the video, and self here as well. So volume is the multiplication of all those 3 attributes. I define a class, pass those values to width, height, and depth respectively. And then I say, show me the name, and that is what we can see. But here we have the volume, also we have the area, which is the multiplication of 10 and 20, which is going to be 200, right? It's going to show us, it returns the multiplication of those 2, which is 200. And the volume, which is going to be 200 multiplies 30, which is going to be 60,000. And it's going to be the return value of the volume, as you can see here. So now we understand those things. It's the time for us to know a little bit more about properties. The difference between field and action is super clear. The dynamic part of the code, which does something, is the action or method. So it calculates or does something for us. We call them methods. The storage part that contains the values of the attributes that we have, they are the fields. But do we have something between these two? Properties stands somewhere between fields, the values that we have in the memory, and actions, methods. You can have control over the content by doing something like accepting, not accepting, or something. For doing that, you need to say property. And look at the things that we have here. We use @sign property, and then we are going to get the new value from the user. Don't forget to have self, and it's going to pass it into the self.widths. Do you see that? And look at the other thing. So we have two things. One is property, that we say widths.setter, guys, setter and getter. For the getter part is it's this one that you return just the value that you have there inside the widths field, guys. This is the field. This is the field. And when you say property, you're going to get that value from the object that you have already created. Again, if you just say property, by saying that widths, it's going to fetch the value that you have stored inside the field __ widths. This guy's private. The getter part is public. How about if you want to put any value inside there? In that case, you say widths.setter, you clearly mention setter, and then you define a setter by saying self mandatory part, and you get the value from the user and you place it inside that widths field again. This is the value. In many languages, you see that as values. So value is going to get inside there. So Simon said, does attribute work too? Oh, no, we just, okay, let me just tell you here. People use parameters, people use variables, people use attributes, people use fields and properties interchangeably. Simon, this is not very accurate, right? If we want to talk accurately, we could say fields are the parts that they are the locations in the memory, and properties are the gates to those locations, whether you want to set values by using setter, as you see here, or to get values from those fields. So properties are the bridge to bring or to set values. Does that make sense? So if somebody asks you in any interview that is property has a specific location in the memory, the answer is no. They are just the gates. Properties set values to the field, or that's perfectly fine, Simon, but or they fetch the values. Does that make sense? Let me quickly show you something. I'm happy that you raised that. You raised that issue. Please. I'm gonna get to next question after I just a little bit explain this one. So imagine that we have a location in the memory, guys. Now everybody knows that the location for the whole things. Imagine that I have widths, right? I have height, and so on. These locations in the memory occupied by using constructor. But imagine that these two, width and height, we need to use small letters. So forgive me, imagine that these two guys are small letters. Okay, this is W and this is height. To access these locations that we have here, we need to create a bridge. And that bridge is called properties. What is the role of properties? They are accessible because they are public and they have a control. It's like a gate in custom that they check if they are appropriate. So if you want to set something, the setter is responsible to bring the value, for instance, for weights 10, and getter is responsible to bring it back to the program to show. So we apply these kind of things. A kind of good practice is whether you have any control or not, for all the fields that you have, you use setter and getter. That we call it auto implement in many languages like Java and C#. So whenever we want to access private values, we should first define a function that uses property that is the absolute correct thing. But we have two forms of doing that, Jack. One is the old-fashioned traditional that you define your own method, or using the standard new way of using setter and getter. Does that make sense? So the way that we are learning here would be based on those setter and getters. So everybody, please get to this part. Here we have two hidden fields, means when I say private fields, and then we define a getter by just saying property, and then we say self. For the setter part, we get a value from the user and place it inside widths. Remember, the name of that is exactly the same as that's fine. You don't feel, it's very transparent. The way that we assign a value to widths through the property, through the setter part of the property, is similar. It's pretty similar to the things that we use for depths, which is not a private field. We just use that method. So nobody outside, the outsiders cannot understand we have done that. But the control, if is needed, can apply here. You might say, Reza, we don't have any controlling mechanism here, so why should we bother? We should say that we don't have, if that is the question that you receive from somebody in interview saying that, okay, object-oriented, cool, you always use setter and getter. What's the point when you don't have any control? We should say that we don't have any control yet. Means that there is a chance that you come up with this idea that, okay, width cannot be any negative number, or it doesn't make sense if I just have a number like the width is 1 million. That's crazy. The width could be just between something like 0 to 200 maximum. So in that case, if it's outside the range, you just want to raise an error. Does that make sense? So here you have control, but if you do not have it yet, it doesn't mean that you're not going to have it in future as well. So the best practice is using properties. Anyway, so by saying that, if I go to this and I create a new box and just say the name and now the depth and override the depths, look at here. Without any pain, without any problem, we could just, use, but nobody knows that, hey, this one is not a field. Actually, we call these setter widths, but nobody can understand those who just use the code from outside. If what I tell is a kind of quick, I completely understand it's not an easy topic, but the good thing is everything is recorded, and you can watch the videos of those two gentlemen again. And let's go to the next part. We create, well, now I can just show guys the name. Do I use, am I going to use the field or property of the name? Please type F for field, P for property. And the only wrong answer is the one that we don't type. Because if you just say the one that is correct, you are going to find the reason. If you have not correct answer, you're gonna just remember forever that what was the mistake, right? So one person said F, filled. The question is simple. Guys, do we have any property for name here? Yes or no? We don't have any property. So technically we just have field. So technically we only use fields. How about the depth? The same thing. How about the, let me just go through this. How about the widths? In widths, we don't have, we have these setter parts, so we use the property, right? Also for the height, we use the property to set the value 10. And now you can use those values like area, multiplication of those two, and the wall, the volume, which is going to be the multiplication of those 3 dimensions. And now let's go to the class methods and variables. But before I get any further, let's just watch this quick video, which is going to ease the job for us. And I'm going to elaborate on that. So you have a website, but there is a video. I share the video. It's just like 10 minutes.
Hey guys, and welcome back to another YouTube video. In today's video, the second video in my intermediate Python tutorials, I'm going to be going over static and class methods. So pretty much these are just different things you can use within a class, and I'm going to explain what they do and why they're useful. So without further ado, let's go ahead and get started. So because these two things, methods obviously a part of the class, use a class, we need to first create a class. So in this instance, I'm just going to make a class. We call it person. It is a class object. And then I'm just going to start off by making my initialization method here for itself. I'm also going to give it name and age. And move to the next one. So let's just assign.
All right, if you don't mind, let's just put up with my low kind of quality version, and you can just watch it later as well. So sorry.
Under variables here, self.name is name, and self.age is equal to age. Okay, the next method I'm going to make, this one is going to be called getPopulation. Yes, I'll type self. Actually, here I'm going to type CLS, and I'm going to get into what this does in a little bit. And I'm going to return CLS dot population. And now I just remembered that I actually forgot to make this up here. I'm going to make a class variable where I'm just going to say population is equal to 50, like so. Okay, one more method. This one I'm going to call define, and then is adult. And then in here, I'm just going to put age. I'm going to say return age greater than equal to 18. Okay. I'm also going to make one more method down here just to show you the difference between a bunch of these. And I'm just going to call it define display. Okay. And I'm just going to take self. And that's actually all you need. I'm just going to print to the screen in this one. I'm going to say self.name. And then comma is and comma self.age, comma, years old. So this should, if I do this right, it's going to say whatever the person's name is, and then their age, years old. So for me, 18 years old. So now let's create a new instance of this class down here. So I'm just going to call this one new person. And I set it equal to a person whose name is Tim and whose age is 18, like so. And now I'm just going to go through this class and kind of go through what we've actually done here. So pretty much what I've started off by doing is I've created a class variable population was 50. I've done my constructor method, which is just gonna initialize my variable's name and age, and then I've created two methods in here which actually aren't done, and they're called get population, and is adult. Now, the name of this video is class methods and static methods. So one of this is a class method, and the other one is a static method. Go ahead and guess which one you think is which. So I'm going to tell you right now, the first one is actually a class method, and this one here is a static method. And the way that we denote these in Python is by putting something called a decorator above these methods. So it's just an @ sign and then the name. So in that case, static method, class method, in this case, static method. Now, what is a class method and what is a static method? And the best way to explain this is to use an example. So pretty much a class method means that you can call it on any instance of a class. So you don't need to have, for example, I don't know what to say. You don't have to have an object already created of that class. You can just call it on the class. So for here, for example, I've done something like new person, and typically if I didn't have any other any static methods or class method, I would just say like new person dot display or new person dot get population. What this class method allows us to do is do something like this. So we can do person dot get population. Now, person is simply the name of our class. It's not the name of an object of that class. So new person is an object of class person, whereas person is just the name of the class. And if I do that, and I print this to the screen, so I print person dot get population, assuming I have no errors here. Oh, it says it's because I haven't put the little brackets here, my bad. Dot get population. It pops up to the screen and it gives us the value of 50. And again, we didn't have to create an object to use that method because it is a class method. I hope that makes sense. I'll try to explain it maybe one more time really quickly. Pretty much, you don't need to create an object of the class to use any methods that are decorated as class method. Now, also in class method, all that's passed to the class method is, well, class. Because it's not actually an object, we don't need the self parameter here like we need in our initialization method and in any other regular methods that we have. We just need one variable. We can call whatever we want. In this case, I call it CLS, which is going to store, well, what class you're getting pretty well. And then we can add any other parameters that we want. So we have X, we have Y, infinitely many after that. We just need to make sure that we have at least one in there. Because, for example, I remove this CLS like that, it's going to say take 0 positional argument, but 1 was given because the class name is automatically sent into this method when we call it. Okay, the next type of method is static method. And this one is similar to class method, except it can be called without using that class, I want to say. So it doesn't take a self parameter and it doesn't take a class parameter. So you don't actually need anything here. In this case, I have age just because I want to be able to compare age. But it doesn't need any parameters. If I did something like this, it would work fine. So the way we denote that again is with the @ static method just above where the method is defined. And to use this method, I can do something like person dot is adult, and then in here, if I put something like 5, we're going to get back the value of false, which you can see here. If I do a value like 21, we get a value of true. Now, why is this useful? What's different than class method? Static method is just used when you don't need self and you don't, again, need that actual object. And it's just a good organizational way of storing a bunch of methods. So for example, if you had like, I don't know, maybe a math class that you created, and you wanted to have a few math objects, and then you wanted a bunch of static methods that were all stored under that math. So for example, when you use the math module in Python, you use math.round or math.so on. That's an example of possibly a static method or just a function within the math class. You want to organize all your static methods within that class. So you would call like whatever the class name is math and then dot the method, and then you give it an argument and it'll return that and work fine. I hope that kind of makes sense. It is hard to explain if you don't have a lot of good use cases for it. Class method, it just takes the actual class and then it can access anything within the class that's public to the class. So here you see I use cls.population, and population is a variable defined up here. This static method, it can't access this population variable because it doesn't have access to the class name, right? It's not past that information. So it can only use the parameters that you pass it. It can't use any that are defined within the class. And that's really the best way I can kind of explain it to you guys. And a good way to understand how to use this, and why they're useful is to use them in your own, use case.
Okay, if you can hear me clearly, please type 1. The whole idea is just to, thank you very much. The whole idea is just to have a general info, and I'm gonna explain a little bit more. Very simple, we normally have some methods inside any class, but what are the static class that we saw in the example there? Look at this one, it says you can declare a static class variable. When you say static, means that it doesn't belong to an object, but it belongs to a class. Well, by declaring a variable outside a constructor or class or methods of a class. So if you define a class like class box here, number of boxes equal to 0, it's going to be a static class variable that you just need to say box dot, and then you can just have number of boxes. Look at this one. This is defined a static class variable. And if I say, please show me the value, it's going to show you 0. But look at the thing that we have here. If I say the box dot number of boxes, the class level value that we have for that variable is going to be 100. Is it possible to create one object out of the class? Yes, and say now go to that specific object and get the value of that. Yes, it is possible, and it's going to show you what 100. What if I change that specific object's value? You see, I change it to 5, and it's going to show you 5, no problem. But can you please guess what would be the output of box1.num boxes? Anybody can guess. Is it going to be 5 or 100? Who else? Okay, we don't have that much time, so I just answer it. Yes, it is going to be 100 because that's the class level that we didn't touch that one. This guy, the object, got the value initially from there, and we override just the value for that object, not for the class. And the class still is intact. You can modify the value of that separately. You can modify the value of that box number here and say it is equal to 777, for example. And then you say that what is the value? You change that in the class level, not the object level. So the class method, kind of in a similar concept, we talk about the class, not the object, not self. So it's something that happens in the level of the class. You might ask, what is the example that you can just clarify more? Imagine that you want to write a program, a game, that the number of cars that you're going to participate in a game would be 10. I repeat it. Imagine that you want to write a game application that you can just have, when you start the game, you can just have 10 cars, car 0 all the way to car number 9. In that case, if you define a variable which belongs to an instance, means instance level, if you create a new car and you increase the number of car numbers, it's gonna always be 1 because it's in the object level. But in the class level, if you create any new car, you can just say, okay, go to the class level and update that class level variable, static variable, that kind of thing. So it is on top of the objects, not inside the object. Okay, how about the methods? If you want to have a method that you don't need to define any object to use them, you need to define them in the class method. Just to give you a simple example, whenever you just give me a second to find the text. Okay, here it is. Imagine that in many of the languages, for instance, C#, we never say math equal math, my math, and say equal to new math. Then we say my math dot is square root SQ RT of 100. We never use such a thing, right? We always use math.sqrt. We don't create any class to access the methods like square roots, sine, and so on. Does that make sense? They are class level methods, so they do not need to have an object to be accessed. Here, if you say class method, in this place, you don't say self, this time you say class, and then you can just, for instance, return the value or something that you want. It's in the class level again, not instance one. So let's see what we have here. As you see, we decorated the class method like this, and we said CLS. And as it was explained in the video, in that case, I can say, hey, go to the class level and show me the name. What is the name of this class? Very simple, box, and we just add those kind of frills into it to be more explanatory. So it's going to say box is, which has come from the class level, is the name of that. And what if I say, okay, let's create an object, and again, you're going to use this one. But what if you say, how about accessing that through an object that you have created based on? It doesn't make any changes. It's going to still call that class level. But what is the static class method? In that case, you do not have anything like self or CLS, and you're going to just use the if you want, we have a hidden private property that is the class of field, which is mentioned here. Let me just go to this example. Here I said a static method, I'm sorry. And in that case, I use that private class, right? And then set dot name. And look at this one. Here is the box. And we can just access that using the field of the class. It doesn't have any self or something, right? So this is the last box that we create. And if you create an object based on the latest thing and you call that a static method, it does exactly the same thing. In other words, it's not restricted to either class or object. So reading this one is going to help us more to understand what are the differences between class methods and static methods. I have provided more documents. I hope it was fine. My apologies to keep you 1 minute extra. We are going to work on that in the lab exercises that we have provided for this week. You're going to understand the concept thoroughly. Hopefully, you're going to enjoy the lab. If there is no specific question or concern, thank you very much. Have a wonderful one and take care of yourself. I'm going to upload the video in a few minutes, but please wait for a couple of hours to receive the highest quality possible. Have a good one. Take care of yourself and bye. Yes, as always, can you please just go to the quiz and check if the quiz is there? Just one person, if you check, please just go to the quiz. Assessment and quiz. Can you see it? Is it accessible? Thank you very much. Have a wonderful one. Take care. Bye.